Hello everybody. Here are a couple problems from section 2.4 that I didn't do. Example 5 is one of them. So we're asked to find the equation of the tangent line at the given point. All right, so of course to find the equation of our line, we first want to find the derivative. And so we'll have 3 minus 6 sine x. And then we will have to find that will give us our slope, but we want to find that value when our x value is pi over 3 in this particular case. And we know that the sine of pi over 3, use your unit circle if you don't remember, is root 3 over 2. And we'll get some canceling done there. And so our slope is going to be 3 minus 3 root 3. Now that looks a little intimidating. Don't be intimidated. This is still a slope with an x and a y point. So in green, I'm going to go ahead and do my point slope form of a line, which we're all familiar with. And we're just going to plug in the y value, the m, right, and the x value. And if you like, you can go ahead and distribute this, FOIL this, what have you, but I am pretty happy with this form right here. The next problem that I did not do in class was example number 7, I believe it was. Here we go, with the elastic band. So we have an elastic band and we have a mass that's hanging from the bottom of the elastic band. So when this band is hanging from a hook, right? So we have a little hook here and our band is hanging from it and there's a weight on this band. We'll make them look a mass, I should say. Now, this mass is going to vibrate back and forth. So when it's not vibrating, we'd say that's equilibrium. But as we pull on that band, it's going to move up and down. When we read letter A, they ask us to find the velocity and the acceleration. You guys are pretty good at that so far. Velocity is just going to be the first derivative of our position. And then our acceleration, I can do that in a different color, is going to be the derivative of the velocity or the second derivative of the position, right? And they do ask us to sketch those. You can go ahead and do that on your graphing calculator. And letter B asks for when does the mass pass through the equilibrium position. So please remember the equilibrium up here was when our mass is just hanging still, when it's done oscillating back and forth, right? Let's see if I can spell that right. Equilibrium. There we go. All right, so our equilibrium here is when our position equals 0, correct? So we go ahead and set our position equal to 0 here. And we go ahead and solve. I just got a trig function on each side here. I'm going to go ahead and isolate my sign. Move over here a bit. And please notice that if I were to divide both sides by cosine here, this is just going to give us tangent. Sine over cosine is tangent, yes? So tangent is going to equal -2/3. Okay, now we might have forgotten this a little bit from pre-calc, but one way we can figure out what is t here is you can take the inverse tan and go ahead and punch that in your calculator, and when you do that, we're going to get about -0.588, and that's going to be t. Now, please remember, I'm going to draw in green here. Please remember our all students take calculus, right? All students take calculus. And we say to ourselves, okay, we have a tangent that's going to be negative here. So tangent is negative in the second quadrant and in the fourth quadrant, right? So we already got one of our angles. He's about here, -0.588. And what would we have to add to that to bring us into the second quadrant? We would have to add pi to that, right? Because it's half of a circle. This can get a bit tricky, I know. So in order to find our t that's in our second quadrant, we're going to take our 0.588 and we're going to add pi to that. Go ahead, plug that into your calculator. We'll get about 2.55 seconds. And I'm running out of some room here. Let me move this up just a little bit. So from here, they ask us what is the velocity at this time, right? So if we're looking for the velocity, we simply go ahead and take our velocity function that we found in part A, and we go ahead and we punch this into our calculator.